you see the headlines every day. AI, ChatGPT, what's coming next? But behind all that noise, there's this incredible story of huge intellectual bets, massive engineering gambles, and just unbelievably rapid evolution. So today, we're going to unpack that story. We're going to see how GPT climbed from this quiet little experiment to a global phenomenon in just 7 years. And that's a really good question, right? Because this wasn't some slow, steady march of progress. It felt more like a series of explosions, one after another. And to really get it, to understand how we got here, we have to go back to one fundamental breakthrough that honestly changed everything. So we're going to trace this whole journey, like a climber's ascent up a massive mountain. We'll start down in the foothills, before GPT even existed. Then we'll make our way up through the first experimental base camps, witness this great leap of scale, and finally, check out the view from the summit. Okay, so let's set the scene. Before 2018, the world of language AI looked totally different. I mean, the models they had were clever, for sure, but they all shared this one critical bottleneck that kept them from ever truly getting big. The difference here is just profound. On the one hand, you had what are called recurrent neural networks, or RNNs. Think of an RNN as trying to read a sentence one word at a time, desperately trying to remember what came before it. It's slow. And because of that, it really struggles to connect the beginning of a long paragraph to the end. But then you have transformers. They see the entire sentence all at once, in parallel. This lets them understand the relationship between all the words simultaneously. And that right there was the absolute game changer. And this is the blueprint for that revolution. This 2017 paper, Attention is All You Need, great title, by the way, introduced the transformer. It works using this mechanism called self-attention. It's basically this clever way for the model to weigh the importance of every single word in relation to every other word as it's processing. It doesn't have to remember things in a line, it just sees the whole context at once. And this is where OpenAI made a huge bet. The common wisdom back then was that you had to build specialized AI for specific tasks, one for translation, one for summarization, and so on. But OpenAI gambled. They bet that one huge general-purpose model pre-trained on a massive chunk of the internet, could learn to be good at pretty much anything. It was a really controversial idea, and it set the stage for everything that followed. So, the bet is on the table. Now what? Well, OpenAI took its first few experimental steps up the mountain. And these first couple of models, they weren't about showing off raw power. They were just about proving that this whole concept could even work. So here we have GPT-1 with 117 million parameters. Which I know sounds kind of tiny now, right? But its real importance was in the method. It proved you could pre-train a transformer on a big dataset and then fine-tune it for specific things, and it would beat the older models. And here's a fun fact. Its training data included something called book corpus, which is this dataset of unpublished novels. That's probably where it got its surprisingly good knack for storytelling. Then, just 1 year later, wow, the scale jumped dramatically. GPT-2 came along with over 10 times the parameters. And this is where things started to get really, really interesting. And honestly, a little bit scary for the researchers themselves. GPT-2 was so good at generating text that was coherent and believable that OpenAI at first refused to release the full model. They were terrified it could be used to create fake news or spam on an industrial scale. And this was a critical experiment in governance. It was really the first time a major AI lab had to publicly wrestle with the ethics of its own creation, which made the story of GPT not just technical, but political too. So after all that caution with GPT-2, what came next was a moment of just pure, audacious scaling. GPT-3 wasn't just another step up the ladder, it was a vertical leap that required a whole new level of engineering. I mean, just look at that jump. From 1.5 billion parameters to 175 billion. That's more than a 100x leap. Training a model this massive was an absolutely incredible infrastructure challenge. The hidden story of GPT-3 is really one of distributed computing. And solving that puzzle wasn't just some cool engineering feat. It was the key that would eventually let them put this power into the hands of millions through products like ChatGPT. In all that scale, it unlocked a kind of superpower, few-shot learning. This meant you didn't have to do all that complicated fine-tuning anymore. You could just give GPT-3 a couple of examples right in the prompt and it would just get it. It could write code, draft emails, summarize documents. But, and this is a big but, it had a huge problem. It was completely unpredictable, it made stuff up, we call that hallucinating, and just gave chaotic answers. It was brilliant, but it was also totally wild. So, how did OpenAI tame this brilliant but wild model? How did they turn it into a helpful partner that millions of us could use? Well, the answer wasn't more scale. It was a really clever new way of training it. The solution was a technique called reinforcement learning from human feedback. It's a mouthful, I know, so we just call it RLHF. And this was the secret sauce. This is what made ChatGPT possible. It was a way to systematically teach the AI what we humans actually find helpful and harmless and polite. It solved that whole problem of chaotic, untrustworthy answers. So here's basically how it works. First, the AI model generates a few different answers to a prompt. Then, a human comes in and ranks those answers from best to worst. All of that ranking data is then used to train a separate reward model. You're essentially teaching an AI to predict what a human would rate as a good answer. And finally, the main model gets trained over and over again to get the highest possible score from that reward model. It's almost like giving the AI a conscience that's been trained on our preferences. And that's it. That's the thing. The reason ChatGPT went viral wasn't because of more parameters. It was the GPT 3.5 model, fine-tuned with this RLHF process, this alignment with what we actually want. That's what made it feel so different, so trustworthy, and so incredibly useful to millions of people, seemingly overnight. Okay, so we've reached the summit with ChatGPT's amazing conversational ability. But the exploration didn't stop there. The next phase of the climb was all about expanding the horizon, making the model see, hear, and become way more accessible to everyone. The GPT-4 family then pushed the boundaries in three really key ways. First, GPT-4 just shattered the text barrier. It became multimodal, which means it could finally see and analyze images. Then, GPT-4 Turbo came along and tackled the practical problems of cost and context, making it cheaper to use and able to process huge documents. And finally, GPT-4o delivered on the dream of real-time seamless interaction, understanding text, audio, and vision all at once with almost no lag. So, after this absolutely breathtaking climb, where does that leave us? Well, when you look back, the entire journey reveals this really clear, accelerating pattern of evolution. You can literally see the entire ascent right here. From GPT-1 struggling to string a paragraph together, to GPT-3's wild creativity, to the aligned helpfulness of 3.5. Then, you see GPT-4 being able to see the world, and 4o having a real-time conversation about it. Every single step built directly on the one before it, tackling a new limitation, and setting the stage for what's coming next with GPT-5, a true partner in reasoning and problem-solving. And that brings us to a really important point today. The evolution of GPT is completely inseparable from the evolution of OpenAI itself. This isn't just a story about technology, it's a story of an institution that is constantly trying to balance being a breakthrough research lab, a global product company, and a massive policy experiment, all at the same time. Which leaves us with one final big question to think about. As we look back on this 7-year journey, it starts to feel like this is more than just a history of a technology. It feels like we're witnessing the very beginning of a new kind of relationship, a relationship between us and a new form of intelligence, one that we're all still just beginning to understand.